I think with every single iteration of Spark that we see move through, Spark sort of reinvents itself a little bit to the point now where it almost doesn't even feel like it's truly just an engine anymore. Like it almost feels like a full data platform.
You're listening to It's About Data. In episode 78, our guest Lisa Cow joins us to discuss the past, present, and future of Apache Spark. Lisa, welcome. It's been a long time coming, this podcast episode. We tried to schedule this many times. I'm glad that we finally made this happen. It's going to be a fantastic conversation.
And here's the interesting thing, Lisa, is that you've been a Brickster now for about 6 or 8 months. And you've been talking about Spark 4.1. And to me, like, Spark just seemed to be so 2015, but evidently it's come, as they say, a long way, baby. But anyway, but as I said, tell us a little bit about yourself, and then we're going to find out what's really sparking you these days.
Okay, I love a good pun. I really have to point that one out. So my name is Lisa. I have been at Databricks now, like you said, for about half a year, a little bit more than that. And I'm a staff DevRel, really focused on the open source side of the house here. Previous to that, I was also with another Apache project called Apache Gravitino in the cataloging space. So always just kind of been around big data, open source, and this sort of intersection between community and engineering.
Nice. And I think part of the reason we convened this recording was to discuss new features in Spark and what they might mean for data engineering and, of course, for AI. You will always
4.1 just seems to be just a huge advance, the biggest we've released in Spark in years.
It really is. And I think with every single iteration of Spark that we see move through, Spark sort of reinvents itself a little bit to the point now where it almost doesn't even feel like it's truly just an engine anymore. Like it almost feels like a full data platform in this one project. And part of this is just the ecosystem has really just been so strong around it. And so when you have year over year, so many contributors and community members and large companies invested in this project, it just grows in all directions at once.
Yeah.
So what would you say? I mean, put it this way, you put some great videos up on LinkedIn, which really summarize this, and we'll certainly put a link, in the notes for here, for the, when we release this. But talk to us, some of the major advances. I mean, the thing that initially, there are a whole number of things, but the declarative pipelines, the structured streaming and so on. So, Lisa, why don't you go through basically some of the highlights that you've seen with 4.1?
Yeah, like you mentioned, so Spark Declarative Pipelines is a new way to author data pipelines in Spark itself. So instead of hard coding so many of the sort of like boilerplate management that you might have, like the retry logic, actually starting the Spark session, and then also figuring out all of your dependencies or parallelization, what you do instead is that you declare the actual logic and the data sets that you want. And then Spark now offers this new sort of API interface where you can dry run that and without actually processing any of the data itself, and then catch dependencies and errors and actually have the engine itself manage all of the parallelization and execution logic for you without having to actually think twice about it, which is really cool. And this works natively within Python and SQL, and it actually supports both batch and streaming, where it's just a very nice unified interface for it. But if you're new to Spark or you haven't touched Spark in a long time, I think writing pipelines in this way is just so much simpler and much easier as an entry point compared to traditionally Spark is like very complicated to get started with.
Oh gosh, yes. Yeah. I mean, the whole idea of doing declarative, huge step.
Yeah. Well, it's interesting because Tony likes to talk about the zoo animals of the Hadoop world, right? Like you have all these different components. You had the zookeeper that you had to manage, and you had, I don't even remember, but all these different parts that you had to get going in order to do anything, basically. And part of the reason the cloud was so successful is that it brought convenience to data processing, right? You just sign up and you spin things up and it's taken care of. What I love about this is that we're kind of bringing that same mentality of simplification to open source and to engineering and saying, let's take care of the stuff that's kind of automatic and then let you worry about the details of the data.
Yeah, I completely agree with that. And one of the shifts that we're noticing, at least within something like Spark that's just so pervasive and large, and pretty much you'll see Spark deployed in any sort of large company running any sort of like significant data infrastructure, is everything's congregating around one single API now, and it's easier to extend that API
Mm.
in different ways, like batch and streaming and like low latency workloads or MLAI, versus trying to run multiple engines at the same time at once.
Hmm.
And what
Hmm.
we're noticing now is Spark has really expanded its scope out, but the interoperability between the other engines is still there. And so
Hmm.
you're
Hmm.
noticing a lot more
Mm.
delegation in terms of what, I would even call like the sort of, I guess, workload offsetting or offloading to
Hmm.
different engines, but it's still kind of being routed through Spark in a way, which is something that I don't think we've ever seen before
Mm.
in data engineering.
Yeah. Yeah. And actually, the last time when you were in New York and we were talking remotely, you were sitting in a cafe, we talked a bit about Spark NLP. I've actually given some workshops on Spark NLP recently. And one of the things they added, it now does word embeddings, but you can go beyond that. Well, actually, full text embeddings using LLM type embedding models, but you can embed
Mm.
audio and video and like pretty much anything you would want to in an embedding preprocessing pipeline. It's like, wow, this is really cool. Like you can use Spark seamlessly to load your vector database without having to worry about a bunch of different engines. It just takes care of that for you, just like you were saying.
Yeah, absolutely. And the feature engineering within Spark has really quite matured a bit. Like
Yeah,
MLlib has been around for a while and it's been tested at scale. And
yeah.
now we're introducing all of this interoperability between these other engines, but also formats as well.
Hmm.
Like, we're seeing LanceDB being supported through PySpark and all of these other tools in the Python ecosystem. Now all of a sudden you've extended that out to, generative AI and whatever workloads
Yeah.
or data training that you need to do there.
Yeah, it's really interesting because for I think probably one of the earliest issues that hit Spark was the fact that it was conceived separately from Python, and that
Hmm.
in the early days it was kind of like a sort of like a rough handoff between them,
Yeah.
and and I was wondering if you can kind of go through this a little bit. There's some new enhancements with PySpark, and what's kind of interesting is talking about how that it allows you to now kind of bypass the pandas step. I remember when pandas was, I remember, having to do with West McKinney, right after pandas came out. And I'm thinking like, wow, this really come full circle here. But can you kind of, speak more in general in terms of how Spark really has really built better bridges into the Python world?
Yeah, I think this is one of the more confusing things people have around Spark is
Hmm.
Spark evolves and adapts to every single step of the ecosystem. It doesn't wait until something is a standard and then catch on to the train. And so even if you look at something like, the user-defined functions that you might have, and initially a lot of those early user-defined functions within Pandas and within PySpark leveraged a lot of that ecosystem. And we've seen that now evolve into using like Arrow native UDFs, having just,
Hmm.
native data frames. And all of these options are there, but it can be kind of confusing to navigate through. And I don't blame people because you're looking at like a decade of history there, but it
Hmm.
also tells us that, whatever comes in the future, it's going to be supported. But if you want the latest and greatest, you do have to have the latest version of Spark and then really understand, hey, what is the most recent thing that would help my particular workload instead of always just kind of relying on the basics that might have been, out of the box at the beginning.
Yeah. Yeah. I mean, it seems like it really pays to stay on top of those Spark release notes and see what's going on because things do not just change, but improve so fast. I mean, I think, to be frank, the reputation of open source software is that we're always introducing these breaking changes and it's a huge headache. And, Python 3 comes out and all this code breaks and then you have to go
Yeah.
fix it. And it's nice when there's just a focus on like functionality to optimize things that people need to do all the time. Now, one of the things that Tony mentioned was structured streaming, and apparently there are a lot of big improvements
Mm.
in the new engine. And there's been this very pedantic debate amongst data engineers since structured streaming was introduced about whether it really counts as streaming and whether it really counts as real time, right? So maybe you can address
Oh,
what's
that's just so
changed.
micro batch.
I mean, yeah, exactly.
So the term that I've used recently around this is that Spark offers like a spectrum of latencies versus just the fastest. And I think that actually works well if you think about the different type of workloads that you have.
Yeah.
So for those of you who haven't been caught up, in 4.1 recently there was introduced a new type of execution model in Spark structured streaming called real-time mode. And it does
Mm.
sound exactly like it is, which is like the
Hmm.
super low latency execution model that can support like operational use cases is what we're thinking. because Spark traditionally has been working from this framework of batch, right?
Yeah.
And even in the term micro batch, we see that there, where we're just reconceptualizing streaming as smaller batches. And I think now we've evolved to move past that a little bit.
Mm-hmm.
Micro batch is actually quite performant and, serves a ton of queries, but moving now towards real-time mode, we're able to extend that API to be able to meet these sort of levels of performance that maybe Spark wasn't able to meet before, but now you can actually switch right to it. One of the really cool things about real-time mode is that you're actually able to process new data as it's coming in. So you're continuously polling and looking for fresh data instead of waiting for whatever small batch window is full and then processing that and moving onwards. So I think it's a really awesome thing.
Well, that basically dispense with the need to, let's say, to swap out the Flink.
Yes. Yeah.
Okay, never ask a yes or no question. I should have learned
that. Yes, and I think is the improv thing I'm supposed to do here.
Yeah.
But yeah, it really is just easy to switch out. So if you already are using Spark structured streaming, and if you work with Spark, you're working with a ton of configs already. And if you're sick of managing all those configs, maybe look at declarative pipelines on how to manage those a little bit better, or the newer Spark models. But really, you can just change the actual type of trigger point to be real time instead of, just using like a specific bin. So it's one line change, which I think is really nice. And it makes migration a little bit easier. And that's one of the things that Spark probably has a larger issue with, is that there's so much custom work on top of Spark to make it work in these very large infrastructures. That can be hard to actually switch or migrate over different workloads. And so really concentrating on making that user experience much easier, not just for humans, but now for AI, I think is a great focus for us.
Yeah, if you think about that, it really, from that standpoint, Spark becomes a victim of its own success, because any technology, any framework that becomes popular, at some point you have to think about, how do we basically deal with the legacy that's out there, because it is so popular.
That's fair.
Yeah, absolutely. And I think we're noticing that just generally across the entire open source data engineering ecosystem, like we've noticed the IRC has really taken off. This idea of interoperability and being able to have composability and being able to easily switch things in and out makes it much more attractive in today's age. And we're noticing that, we need to make systems and architectures that can evolve, and that includes tooling itself. And I think the Spark project is a really great example of something so large that still embodies a lot of that mentality.
Yeah. I mean, it's funny. Let's rewind to 2022 when ChatGPT came out. And I feel like at the time, Spark was maybe on its back foot a bit. There was a sense that it was just more complicated, that most teams using it really didn't need to be using Spark and could use something much simpler like SQL. And I feel like Spark built off of that AI message and said, hey, we're the platform for doing a lot of the stuff you need to do with AI, like text processing, where you can't do that with SQL the way you can on Spark. But then the thing that's exciting is that the platform has really evolved to actually deliver on those AI use cases. And I'll just ask you this, like, what other conversations are happening in the Spark community about what needs to happen to support AI use cases? Like, what else do we need to accomplish here?
Yeah, I think multimodal is the really big next step. And how do we prepare something like the data source version 2 to be able to support all of these up and coming formats that we're seeing that, as we know, will kind of evolve, right?
Yeah.
A really good example of this is that you might have Parquet as a format evolve to be able to fit more of these use cases, vectorization, et cetera. But in general, we're also going to see new tools evolve. And the job of something like Spark is to be able to support both at once and all of these different engines that are meant to fit these specific use cases as well. Like we have things like Polars, for instance, et cetera. And so how do we create a composable system for these different AI tools to be able to leverage it? And of course, you mentioned, MLOps before and being able to do feature engineering. I think one of the weird parallels that we'll see here is that on top of the capabilities, we're noticing that there's an expectation for performance, which is where I think a lot of, again, real-time mode comes in. So we've seen real-time mode being used for these sort of like feature engineering pipelines in real time, and really being able to accommodate that, because I just don't think that the capability itself is enough anymore.
And I'd like to follow that up because it's very interesting how, with Matt asking about looking ahead, what the community needs to basically be looking at. From your observations being in the community, how would you say that the Spark community has evolved? Because obviously it's now been around for some time, and what's remarkable is that in technology, being around for a long time means you become obsolete. And Spark clearly hasn't. The community must have evolved. What's been your take on how the community itself has evolved?
Yeah, so I have not been part of the Spark community since its inception, and I think that's
Yeah.
kind of an interesting thing because I've been able to be part of it despite being kind of new, which I think would surprise a lot of people. There's some folks who are really passionate about very specific slices of Spark, and if you want to get involved, please do reach out to those folks. And there's a
Mhm.
PMC that's enabled um, in the committee that are really passionate. I think one of the things that people have a tough time with is not knowing who, contributes the most to what and how to even find the communities within Spark itself. And so instead of having one major Spark community, which you will see, instead we're noticing a Spark ML community, a Spark streaming community, a Spark Python community, even, C++ clients and things like that that I've seen, Spark Rust. And there's just so much that's going on now that you find your pockets and you get to embody that.
Nice. Well, thank you so much. I think this is a really good introduction for our listeners and stuff going on in the Spark
Yeah.
community. And I'll have you send me some links of things that they can look at, some of the videos you posted and such lately about what's going on. And we hope to have you on as a guest again sometime, maybe
Yeah.
for some big announcement or something like that. Thank you, Lisa.
Thanks for joining us.
Awesome. Thank you so much.